None of that went into the recording. Gosh, doing so great tonight.
So start over, say hi everyone.
Hi everyone, I am still incorporeal, where you're missing my head. I am Erik Johnson, and you folks have now heard me say that maybe 2 or 3 times. I'm going to turn off my green screen component to Zoom there. Now you can actually see I am wearing a green shirt, so maybe I can look almost professional for this show. Waylena, please, because it is the beginning of the night, you got to show everybody what space cat you're wearing.
Oh, I'm wearing the cartoon Space Cat astronaut. It says Space Cat, and it keeps disappearing into my spacey background.
That's right.
So I'll have to use a different background later.
That's okay. Your catstronaut is always welcome.
But I have made my own Space Cat, but it's going to be a few weeks before it gets here. But it'll be my very own first Space Cat.
Wonderful, wonderful. Well, folks, tonight, what I'd like to hear from all of you, feel free to use the chat to ask us questions. You can use the Q&A as well if you wish, if you want to stay anonymous. But really, even though this session is being recorded and will be kept up on YouTube for eternity, they won't be able to see your questions. What I can say is that if you folks, I would love to hear where you're from, what your favorite planet or starry night object is, or just, maybe you have a request for us, what you'd like to see tonight. For those who were on here a few minutes ago, I was playing with one piece of free software that you can use to simulate the sky. And then I've got another one that I'm about to share with all of you right now. The one that I tend to use for these public shows is Stellarium, because it allows me to stay at my workstation for this. And it is a nice piece of free software that you can go and install on your own computer, or you can use a web-based version that has some of the features removed, but it's still pretty cool. I don't think this is the exact right now time, so let me go ahead and check that out. I think actually it is actually correct. Let me see here. Oh yeah, 7:03 p.m. This is right now. What you can see that is very inaccurate about right now is that I'm pretty sure if I stepped outside, I would see full cloud cover. We even have some chance of rain tonight, and that's obviously no fun. Oh, I was trying to see what the chat was saying. I'm so sorry. I was trying to see that there. But at least with Stellarium, I always can look and simulate the sky no matter what time it is. Oh, I see. Was in the chat you sharing some of the Stellarium links? Is that right? Okay. All I can
sharing
say
mood.
Yeah, it just didn't show up, and that was why I was very confused. All right, so in Stellarium, you can have all sorts of backgrounds, but for me, let me try this. There we go. Oops, there we go. But for me, I have a background that shows the actual planetarium, because I love actually sharing the planetarium with all of you folks, even if it's just a nice picture. This picture is actually a 360-degree image that Waylena had gone and taken last year so that we could at least simulate the planetarium through Stellarium at the same time. So this is the sky that it might look like on a very nice and sunny day. And you can see that even though the sun is looking like it's about to set over there, which tells you that you are looking in the west, what you'll find is that there's this other bright object coming up above the planetarium over here in the east. And that object is actually, yes, it's the moon. All right, so let's go ahead and click on it and get a look at what the moon would look like tonight if we could get a good view of it. Ooh, look at that right there. Very nice. So you see that the moon is almost completely full. It's not all the way there yet. Still got a couple of days to go yet. I think the full moon's roughly on Monday or so. And you can see all sorts of nice features on the surface there. I even see a couple of little streaky lines. Those are telling me what are called crater rays. When craters form on the moon, the explosion, the particles just fly off in every direction. Here on Earth, if you've got some sort of explosion, it forms this nice mushroom cloud. But on the moon, you lack an atmosphere. So there's nothing to slow it down. So it flies out and leaves these streaks over the surface from the youngest craters. These dark patches that you can see there, those are what we call the lunar seas. And the reason why they're called seas is because to the earlier astronomers looking at the moon, when they would see it, it almost looked like seas to them because there were so few craters there. Nowadays, we know that those things were liquid once, maybe billions of years ago. And the liquid there, though, was liquid lava. All right. Those are actually filled in lava basins. Once upon a time, the moon actually had very deep impact craters there, but it was when the moon was still geologically active. So those crater basins actually got filled in. Really nice to look at there. A moon that's nearly full like this, you can easily see it at night. If you can get out in a place where there's very few lights, I encourage you to look behind you when you're looking at the moon, and you will see that the moon can easily cast a shadow. It almost gets bright enough to even read to it. It's just always a fun sight. So if you've got a clearer night in the next couple of days, check out the moon. To give you an example of what I mean by this, here's what the moon will look like tomorrow. And then on the next day, I think it's going to be behind the planetarium. There you go. And there's the next day after that. There's the moon right at the horizon. The reason why now something looks like an egg is because those are the goofy effects of the horizon really messing with it right there. All right, where were we at? We were at roughly about there, I think. Yes, that's today. Excellent. All right. So yeah, moon's always a lot of fun to see. Now, if you're going to actually go out and do some stargazing, I recommend you get to some place outside of town. And one place you can go outside of town is over by the observatory run by the Champaign-Urbana Astronomical Society. It got recently named the Prairie Winds Observatory, and you can see what it looks like here in this image, a photograph also taken by Waylena. You can see that they've got this nice roll-off roof building right there. Those piers, those pylons over there, that's what the roof can roll off onto. So they've got telescopes inside of that building. And there's a much larger telescope in this older building right there. They've had this property for nearly 30 years, and you can see it's out among the farmland. So that means that you've got some really nice flat horizons. You're not completely away from the light pollution of Champaign-Urbana, but it's a lot better than what you'd get in the middle of town. So let's go ahead and watch the sunset. There you can see it right there over in the west. Thank you for sharing your favorite planets there, Ellie. It's good to know that you've got 2 of them. My favorite planet is all of them. That's what we call a cop-out answer. All right, so yeah, since this is mid-spring, you would start to see the sun setting at about 7:30 or a little bit later. If you're curious about that little bright spot right there, I have to tell you, I would not expect you to be able to see that tonight or the next couple of nights. In Stellarium, I amplify the brightness of the stars and other objects that are visible at night just to make sure that they show nicely on Zoom and on our recordings. So this object here, don't expect that you could see that in the glare of the twilight sun tonight, all right, or in the near future. But this is giving you a taste of what you're going to see later this year. If you're curious about what this object is, well, I think now is as good of a time as any to click on it and find out. Let's see what we've got here. All right, we'll zoom in, and I'm in for a surprise. I hope that other object next to it just happens to be another one of the planets. Yes, I think they all deserve your love, Ellie. That's absolutely right. Hey, my guess was right. Excellent. So what you're looking at here, and the reason why I know that I'm right, is because I'm seeing not very specific features on this surface. It looks like it's covered in clouds. You are seeing the planet Venus right here. Venus, because of how close it is to Earth and how close it is to the sun, would be the brightest thing you see in the night sky, except for the moon. So that's why Venus is usually referred to as the evening star or the morning star. And now, since Venus is setting after the sun, when Venus can get far enough away from the sun that you can actually see it when it gets darker, Venus would be our evening star. Last year, we were seeing Venus as our morning star, but now Venus has gone behind the sun and it's going to show off in the evening sky over the next several months. It's going to get a little farther from the sun, and it'll be a little easier to see at that point. Now, Waylena, should I click on that other object and see what it is?
Ooh, I want to know. I want to know.
You want to know? What's your guess? Is your
I don't know. I don't know. I mean,
all right?
I always hope it's Mercury, but sometimes it turns out to be a star. But I
Mercury.
always hope it's Mercury because
Mercury
Mercury
is
is
so
just so awesome.
fast. I have not been
Yes,
keeping track of where Mercury is, but I'm
it is
betting Mercury
fast.
is now also over on this side of the sun. Let's find out. Yay, we got it. All right. Yes, that is the planet Mercury right there. Mercury zips around the sun very quick. It takes less than 3 Earth months for Mercury to go around the sun. So from our point of view, we see Mercury zipping around the sun, both west and east of it, very, very frequently. Okay. So Mercury was, just like in the last month or so, it was over in the morning sky, but now we're seeing it in the evening sky. I don't think it's going to get that far from the sun, so it won't be that easy to check, but you can see Mercury apparently is also visible there right after sunset. If you want to see Mercury up close, let me go ahead and click my quick button. There it is. With Mercury in this image, you see it probably reminds you of the moon a lot because you're seeing lots of those same streaks, those crater rays I was talking about with the moon. You see Mercury is riddled with craters. It's larger than the moon, but it doesn't seem to have a whole lot else going on with it. There's not a thick atmosphere there. You just see a crater-covered planet. So that's all you get with this one. All right. Woo, I zoomed out way too far and we made a tiny little planet. There we go. All right, let's go back in. Okay, now I just noticed another thing was starting to come into view over in the southwest. Let's go ahead and check that out and see what we've got there. All right. Oh, there it is. Yeah. So this object, you'll have an easier time seeing it as it gets later in the night because it is the brightest star in the night sky. There is my actual brightest star. I just got myself tricked one more time. There we go. That really bright object is the brightest star in the night sky. Should I give the pun? I think we're getting it recorded. I should give the pun. I am not joking. This is the brightest star in the night sky. I am totally serious. Boo, boo, bad joke, but it's okay. People will be able to watch this whenever they want. So there's Sirius. Now, you folks probably have heard the name Sirius before. Maybe you've heard of it because of the satellite radio station. Maybe you've noticed on that satellite station, the logo has a dog looking up at a star, right? And you might also know from the Harry Potter series that there's a character named Sirius who turns into a dog, okay? Well, that all makes sense because look at that. Sirius is part of a constellation that, well, when you connect the dots like that, it really does look like a dog. And you see that this dog's name is Canis Major, like canine, right? Well, Canis Major just means big dog. There's our big dog right there in living color. Okay, so there's Canis Major. The reason why it's called Canis Major is because we also have a Canis Minor. If I scroll up here, you can actually find Canis Minor. And it's just actually these two stars right there that make up Canis Minor. I know that doesn't sound very original, and we actually have a couple of fun jokes about that in the planetarium, but I can't bring up those images now. So we'll just leave that at that. Now you'll notice there's still a lot of twilight in the sky here, so I'm going to go ahead and go later so that we can get a more properly dark sky. I don't imagine you'd see that many stars at just after 8 o'clock. You probably want to step out maybe at least after 8:30 to really get a good sense of the night sky by that point. So that would be another good thing for you to check out. Okay, so over here in the western sky, there's a lot of bright stars that you can easily see. In fact, if you look to the right of Sirius, you probably notice there are 3 bright stars in a line right there. And then there are bright stars around it. If I click on one of them, let's see what happens. So that one's Alnitak right there. And you can see the stars make this nice shape that looks like a person. You see an arm. This looks like a waist, legs, and shoulders, and so on. Here you can see the person. It looks like they put them in a kneeling position. This person's name happens to be Orion, probably the most famous constellation in the night sky because of how bright those stars are there. All right. So the point is for Canis Major and Canis Minor, those are basically Orion's 2 hunting dogs. That's a good way to imagine them. All right. with this constellation, I was kind of thinking of shying away from talking about it because although you can still see it in the southwest tonight, in the coming weeks, it's going to set earlier and earlier. So here is what the sky looks like at 8:33 tonight. Here's what it looks like tomorrow and the next day and the next. And the sun's just getting closer and closer to this object. So you're going to have a really hard time seeing it in the near future. This Orion, this constellation is actually one of our winter constellations. And since we're now almost in the mid-spring, that's why Orion's just getting really hard to see. It might be that you just kind of want to let Orion rest for a few months and start to look for it again in the late fall. Okay, so if you don't see Orion when you are out looking at the night sky in the next month, it's okay. It's just because you were looking a little later in the evening. So with that in mind, let's look for something that you can find instead. We're going to go ahead and head over to something that you're not going to miss any evening. Okay. Ooh, that's a good question for Waylena. I guess we'll just have to say stay tuned for those plans, or what do you think?
Yeah, we haven't got schedule figured out yet, but we're starting to work on it, trying to figure out who's going to be where through the summer, because I'm probably going to want to do the shows from the dome. So we need to make sure that I'm going to be there for it. So just trying to work out all the scheduling.
Yeah. We will let you know what new shows we add for the summer, and just stay tuned, and thanks for your patience, everybody. Just like we're having to be patient.
There will be space cats.
That's right. That's right. There will be space cats. Okay, so what I'm doing now is I'm looking over in the northern part of the sky. Since we're in the northern hemisphere, the northern part of the sky is the part of the sky that we can see all throughout the year. All right. And I wanted to find one easy object that a lot of you might recognize, but at this time of night, it might catch you a bit off guard in what shape it is. So let me go ahead and draw it out for you so that you can see what I'm pointing out. Here's 2 stars, here's a third, here's a fourth. There I finish off my lovely little trapezoid. 5th star, 6th, and the 7th. Okay, so those right there, some of you might, imagine what you can see right there. I'm betting you folks can see all sorts of different things. Maybe some of you see a spoon or just a pot with a really long handle. Maybe you see a knife. Ooh, I don't know. Or you could just see a kite. Waylena, do you see a shark? You've seen a shark sometimes, haven't you?
I do.
Yeah, that's okay. But this here is what we call in the US and in North America, we call it the Big Dipper. All right. In other parts of the world, they give it other names. You might hear it called the Starry Plow. You might hear it called Charles Wagon or Charles Wain right there. The Starry Wagon is another term for it in other languages. All those are perfectly valid, but they're usually unique to somebody's culture. If you're going to ask one of the Greeks or the Romans what they saw, let me show you what they saw. I'm clicking on W right now, and notice that they saw a lot more than just those 7 stars. And they didn't see a dipper or a pan. They saw a humongous bear right there. The bear's name in Latin is Ursa Major, which just means big bear. All right. So apparently the basin of the dipper right there, the ladle, the spoon part or the basin of it, that part represented basically the body of the bear, and the handle of the Big Dipper, that represented the bear's, well, tail. I gotta say, yeah, that tail doesn't look much like a bear's tail. Where did that bear steal that tail from, Waylena? What do you think?
Hey, you know me, I think they're giant imaginary space bears. So, yeah, if they want to have tails, I'm not going to tell them
you gave me that theory that the bears needed the tails to fly in space, right? Yeah, that's right. Just like how Mario needs like the feather to fly or whatever, the raccoon tail, right? Yeah. So, yeah, I guess it's just, whatever magic allows those bears to fly around in space, okay? And I say bears because I'm about to show you another one right here. So we're going to draw one more line here, And we're going to take it from Dubhe and this other star next to it, Merak, and we're going to draw it right over to this nice bright star right there. Okay, and that star's name happens to be Polaris. You might also know it as the North Star. And here's why it's called the North Star. Look right below it. It is right above the N. Okay, there you can see it's very close to this line called the meridian, which runs right from north to south and goes directly overhead. Okay, so Polaris is right there, your North Star. You already see that it's in the constellation Ursa Minor, which means the little bear. And since the bear is smaller, he needs a much bigger tail in order to survive in space. That's obvious, makes perfect sense. All right, but notice that the shape of those 7 stars in Ursa Minor kind of looks like a, well, a Little Dipper. There you go. So that's where you get the name, the Little Dipper right there. Okay, now if we go later into the night, let's watch this. We're gonna go later and later here. You see the stars over in the west, that's over to your left. They are slowly getting lower, and the stars over in the east to your right, they're slowly getting higher. Look at that, okay? But look at what's happening with Polaris. It looks like it's staying in the exact same position. It's hardly moving at all right? And that's why Polaris is so important for all of us. It's great for navigation. It stays in the same spot in the sky all through the night. That's why it'll always tell you where north is. Reason why this happens? Well, as Earth spins round and round and round and round, yes, I love having the swivel chair for this demonstration. No matter what, directly above Earth's North Pole is the star Polaris. Now I'm a little dizzy. Perfect. And Polaris stays there right above Earth's North Pole, and that's why Polaris stays in that same spot in the sky. If you were actually at the North Pole and looked straight overhead, you would find Polaris there. Since we're not at the North Pole, we see Polaris high up in the sky, but not that high up. All right, let me go ahead and show you one other neat object you can find in the spring sky. And I actually have it still up there, so it's kind of giving it away, but that's okay. I'm going to show you another fun way to find some interesting objects in the sky. We're going to use the Big Dipper for this, and we're going to draw another line. Let's see if I can pull this off. All right. This is just a good test for me. There we go. All right. We're going to draw a line from these two stars, the ones that didn't point to Polaris, and we're not going to point up. We're going to point down. All right. We're going to point down over in this direction right there. I know it's not exact, but it gets you roughly to where we're trying to go. So when you point down from those two stars, you find another interesting group of stars right here. And I'm going to draw another line now. We draw from here to here, here to here, here to here, there, and there. Now what I've drawn probably looks kind of like a little hook to you. We were working with some kids this week, and a lot of them thought they were looking at Maui's hook from the movie Moana. I can't blame them for that. That's a pretty accurate assessment. All right. Others might look at this and think, oh, you're kind of looking at a backwards question mark. Or maybe if you're a little older and you remember what the flag of the Soviet Union looked like, it looks like a sickle. Okay. So we usually call this the sickle right here. If you're curious about what constellation we're looking at, I think this will come up automatically. There you go. You can see the sickle or the backwards question mark or Maui's hook on that one. And now let's go ahead and look at the artwork. And you see clearly you're looking at a lion. So this is the constellation Leo. And while we use these two stars over here to point to Polaris, we can use these two stars here to leap to Leo. Now, the reason why you saw the lion up there a little earlier is because look at what's over by the lion's hindquarters. There's the moon right there. The moon is actually technically in the constellation of Leo at the moment. So when I clicked on the moon earlier tonight, that ended up selecting Leo. Okay, you can see it right there. It's just barely on the edge. All right, so you're seeing Leo up there tonight. If you're curious about where it is, there you can see there's Canis Minor, our old pal, the little dog. And you can see the lion is right underneath the bear. All right. Now, I'm going to show you another really bright star that you'll find tonight, and it's also connected to the Big Dipper. Let me see if I can do this one. Yeah, all right. I guess we'll do this as just a standard drawing. I bet you this is going to go terribly. Here we go. So let's look at the handle of the Big Dipper, and you see it's not very straight. It's kind of curved, and it's curved like a circular arc. So let's draw along that arc, and we follow it to find a really bright star. It's a lot brighter than stars like Polaris. It's actually one of the brightest stars you'll find in the evening sky. Not as bright as Sirius, but it's in there in the top 10. And that star, the way I described it, is a good way to help you remember that star's name. Its name is Arcturus. And so what we did was we followed the arc to Arcturus. And Arcturus happens to be in a constellation whose name I really need to address right now. Because if you're looking at that right now, well, Waylena, how would you want to pronounce that? Because you have your camera.
Hey, when I grew up thinking it was called Booties because that's how it looked in the books.
Who can blame you? Yeah, Booties. Looks a lot like Booties. Now, I'll try to tell you what the proper pronunciation of this name is, but you already have stopped listening, haven't you? Okay. The fact is that second O is actually a separate syllable. Maybe you've seen some words like naive. Notice how the I is a separate syllable, or the names Chloe or Zoe. The E's are a separate syllable. It's not Chloe or Zoe. All right. Well, that's the case with Bootes. Bootes. Okay. Usually this is marked off by having the second O with 2 dots above it. But don't worry about that. Like I said, if you end up pronouncing it booties, I will share a chuckle with you. I
I
promise.
still
Okay.
hear it in my head as Booties every time I see it.
That's okay. Enjoy your booties. I will continue to say Bootes, but I'm not going to fault you for it. I mean, we already lost the battle with Uranus. It's just the way it goes. All right. So yeah, here, I'll give you a big zoom out right now, way zoomed out. If you're looking here, yeah, you see the moon over there in Leo. You can see Bootes over there in the southeast. And you can see a couple of other things starting to come up. Oh, wow. Is it already that time of the year? This is around midnight, and we're actually starting to see a couple of stars coming up that we associate with the summer sky. Okay, there's one that Waylena's staring at, and I will give that time to her in a moment, I promise. But over here in the east, these are actually a couple of the stars of the summer triangle that you're starting to see. It's just wild to imagine that they're coming up this early in the evening now as we're in late April. But let's go ahead and go a couple of hours later so that we can give a proper showcase to Waylena's favorite star. All right, that's 1 a.m. right there. This is 2 a.m. And I think 3 a.m. is a good place to stop right there. Excellent. We got a couple of great objects that we associate with the summer sky that we can see over in the south. And let me see if I didn't turn on something. Oof, I knew I wasn't turning that on. Okay, I'll have to check my settings with that for the next time I load this up. If you noticed what just came on, here, I'll show it to you again one more time. Did you see that little cloudy, kind of Milky Way-ish thing over there? What you're
I
looking,
see what you did there.
Yes, exactly. So this area of the sky, you're seeing the Milky Way coming up across the sky. And in this part of the sky, the Milky Way is looking the best, mainly because that's where the center of our galaxy is. That's what the Milky Way is. It's you're seeing a high concentration of the stars in our galaxy, okay? And here, I will go ahead and tell you what constellation the Milky Way is in, just to make Waylena wait with anticipation just a little bit longer here. All right. The constellation that the Milky Way is centered in is over here. I usually don't see the stars in this constellation making the shape they're supposed to make. I see this instead. What I always see here is I see a handle, I see a lid, I see a basin, I see a spout. And then, of course, when I see the Milky Way very nicely, oh, I have to do this right, I always see steam rising out of that spout right there. And that's what I see as the Milky Way. So this is the teapot right here, okay? Yeah, this is a lot of fun drawings here. And the constellation that the teapot is a part of, I have to close that, is called Sagittarius. It is the Centaur Archer. All right. Now, I got to say, it's really hard to see the Centaur Archer with that. And I mean, look, all they did was just put a couple of twigs sticking out of that teapot. All right. That's all you're seeing right there. But apparently the top of the teapot is meant to represent the arrow. This represents the bow. And notice that the arrow is pointed right over here. And let's see if we click on this. And I'm going to turn this off so it doesn't give it away too quickly. Look at that. We see another hook. We see this nice hook right here. This hook actually is Maui's hook. For those of you who watched Moana, you might remember that Moana, when she was out on the ocean, she was using the stars to navigate. And one of those star patterns she saw in the sky was Maui's fishhook. Okay, and that's Maui's fishhook right there. It's very low in our southern skies in the northern hemisphere, but Moana, she's from the southern hemisphere where Maui's fishhook is way high up in the sky. Okay, so you'll have a lot easier time seeing it there. And the constellation this is a part of, well, look, it makes a scorpion. All right, so Maui's fishhook also means the stingers and the tail of the scorpion, and you've got pincers there as well. And the scorpion's name, well, it hasn't changed that much from Latin, and that is Scorpius. Okay, so you see Scorpius right there. And the brightest star in this constellation is this bright red star right here. That bright red star is named Antares. Antares got its name because this part of the sky is passed by a number of planets. Here, I'll show you a line that goes right through this part of the sky. It's called the ecliptic. The ecliptic is the path that the sun makes throughout the year, going through all of the 13 zodiac constellations, and the planets and the moon move along that line as well. One of those planets is the red planet, Mars. And people would often compare Mars to Antares. So Antares just basically got its name from meaning just simply not Mars. That's all it is. Okay. So Antares I don't think people would mix it up necessarily, because Antares, if you're seeing that next to Mars, you would see Antares twinkle a lot more. Yeah, I didn't tell you that tonight, but stars twinkle. Okay. And that's what you would see with Antares there. All right. If you're curious about where Mars is, well, you can call me out on this because I forgot to point it out in our evening sky. I admit this. It was actually visible right after sunset. Waylena, will you forgive me if I rewind the sky? I know it's an unforgivable planetarian mistake, so that's why I asked for permission. That's all right. Here, I'm going to show it to you.
Where people get that idea. We do that all the time.
I know.
It's part of the power of having a planetarium.
I know.
We control the
limitless
universe.
Power. Well, you can go ahead and edit the video and put this back there.
No.
No way. That's fine.
It's fun to go back in time.
That's fine. Yes. Once you have the power to show the sky, we might as well control the rest of the universe. All right. So this is at 9 p.m. right here. You can see our old pals Orion is up. You see Sirius and the dogs are over here. And just above Orion, you see a red dot right there. That's where Mars is. Mars, if you've been watching where Mars has been over the last couple of months, this might look very strange to you. And that's because in the days past, look at where Mars has gone. You see it moving right through there. And there was the moon just now too. Mars has been zipping through the sky as it gets farther and farther away from Earth. The reason why I missed it, I got to be honest, Mars is not that bright as it was back in October when it was very, very close to Earth. Nowadays, Mars just looks like a pretty bright star, so you can easily miss it, just like I did tonight. That's just how it goes, all right? But you can still catch Mars in the evening sky over the next couple of months, all right? But the sun's approaching really quickly, and you're eventually going to lose Mars, and we'll have to see it in the evening sky. Okay, let's go ahead and go back. We were at about 3 a.m. and I turned on the meridian by mistake. That's okay. I'll forgive myself for that. And I think the last things that I'm going to go ahead and show you now are going to be a couple of planets. And these planets were actually over by Sagittarius recently, like last year or the year before, but they've moved a little bit. So let's go ahead and go a little bit later into the night. a little earlier into the morning and see what we can find there instead. All right, so this is the sky at about 4 a.m. And coming up over in the southeast, if you're waking up really early or staying up really late, you might find some bright points of light low in this part of the sky. I don't want to give it away, so I'll just click these in this fashion and let you see what we're looking at. We'll start with the one that came up first, the one that looks actually a little bit dimmer than the other one. We'll center on it and we'll zoom in. I promise you'll know which one this is once you get a close-up view. Ooh, lots of dots around it. You all know what that one is, right? Of course. You are looking at the rings and the planet Saturn, okay? You are seeing Saturn right there. And I love how the rings have these lovely angles. It's just such a photogenic planet. As you heard earlier, it's Ellie's, one of her favorite planets to look at. It's just so beautiful to see. You can actually see those rings through a telescope. If you have a really good telescope, you can see this division in the rings right here. And those rings actually change from time to time, which is a lot of fun to see. Let me see if I can actually pull this off, but I bet I can't. If I were to cheat and show you what the rings look like next year, take a look at how they'll look next year. See, they look a little flatter there. There you see them even flatter in 2023. In 2024, they look almost completely flat. Look at that. In 2025, the rings might actually look kind of boring because they'll be perfectly in line with us. And also perfectly in line with the sun, because notice that there's actually no shadow of the rings on the planet itself. So it'll look like Saturn's rings actually disappear in the near future. Really neat stuff. If you're curious about all those dots surrounding Saturn, those are some of Saturn's many, many moons. Astronomers have confirmed through telescopes that and space probes that Saturn appears to have over 80 known moons. It might have more, but that's how many we've found so far. Yeah, Saturn's got a big family. All right, let's go to the next one over here. Let's see what we can find when we look at this. All right, zooming in. Ooh, we see some dots next to it. Ooh, and this one's pretty colorful. It doesn't have a cool ring system, but it's got some very colorful clouds. And it's a big, big, big planet. All right. So if I were to do this and cheat just a little bit, I want to see what this looks like over the next couple of hours. So here's what it looks like now in a couple of hours. Oh, look at that. Look what's coming up here. So notice this big object. You are looking at the planet Jupiter, the largest of all of our planets. I was telling you this is a big, big planet. You see this great red spot right here? Well, the technical name is the Great Red Spot. I needed the on there. That great red spot is like a cloud, but it's moving around in a very cyclonic fashion. It's essentially a hurricane, and it's actually bigger than Earth. Waylena didn't do the head explodey thing that time, but I will. Yeah, that is a really humongous storm right there.
I was thinking of that, how, it's bigger than Earth, but then I stopped myself and was like wondering, but for how long? Because it's been getting smaller, and my head just went into a rabbit hole, so it forgot to explode.
See, I don't know what to say about how long it's going to last. When it comes to this thing is quite resilient. And there have been observations of the Great Red Spot for well over 100 years, maybe even over 300 years. We do see it smaller than it was first observed up close about 50 years ago. We don't know if it's cyclical or if it's actually going to dissipate over time. We don't know. There's so much we don't know about Jupiter that we have space probes that go around it and are observing it right now. But hopefully we can learn more about how these storm systems are sustained for so long in the atmosphere of this humongous planet.
So exciting, though, to think of these things that we learn about and think, oh, well, it's always like that. But no, we don't know. We need to keep observing and learning and figuring it out.
That's right. Okay. Oh, I went to tomorrow by mistake. I was wondering what the problem was. Oh, no, I was correctly in tomorrow. There we go.
In the
Okay.
right part of tomorrow, not the wrong
Yes,
part of
yes,
tomorrow.
yes, yes. That's all good. King Jupiter.
That time
Queen
travel
Saturn.
thing.
Okay. One big happy royal family, huh there, Ellie? Okay. All right. If you're curious, those 4 objects are all moons of Jupiter. The reason why they're not scattered around Jupiter is because Saturn has an axial tilt just like Earth does, okay? But Jupiter does not. And so because of that, all the moons always stay in a perfect line with each other. And the other cool thing about Jupiter is that when you look at it from night to night, you actually see the moons change from one position to the next. Galileo saw that through his telescope hundreds of years ago, and it helped him figure out that those were moons orbiting around Jupiter. And that allowed him to realize that Earth was not the center of the universe. Okay, did I turn that off again? I did. Okay. All right, so now it's over past 4 in the morning. Wow, it's getting really late here. I think we should just let it go all the way to sunrise and see what we have. All right. There's our pre-dawn right there. The sun's going to come up at about 5:30 or so. By this point, you probably wouldn't actually see Jupiter at that point. It'd probably be lost. I just wanted to remind you of that once again. But there, the sun is up once again. I'm guessing that, yeah, we had the moon set right before sunrise, so the moon is long gone as well. Okay, but yeah, there's the sun that's gone and come back up. As you folks can see, all this stuff really excites me, and I love to just spend hours and hours talking about this stuff. But, you know, I think that you've been up all night. You probably need some rest. And also, YouTube videos don't work well if they're more than an hour long. That's just how it goes. But that said, though, I would love to hear what questions you might have for us. Here, I'll go ahead and stop sharing, and I'll put us back up on the regular screen. You're very welcome. Yeah.
Thank you for joining us.
Yeah, we really appreciate it.
Well, before you go, don't forget, look at the what's behind Erik.
That's right. 2 weeks from now, on May 7th, we are hosting our very first show entirely in Spanish. So if you are interested in getting that immersive experience, learning about the sky in Spanish, or you speak Spanish fluently, I think this will be a great experience for you folks. If you just want to learn about that stuff, I'm going to be really excited to see what is shared and what's discussed among everybody there. But I do not speak Spanish fluently, so there's going to be very little that I'm going to properly understand except from the language of astronomy. It's going to be a lot of fun.
But
So
the presenter, you guys, the presenter is a friend of ours, an instructor at Parkland who works with us a lot, and he's fantastic. So we're really excited to bring him on board and to be able to, well, to introduce him to the community through this.
Absolutely. So Ellie, your question, are there things like an Earth in their Goldilocks zone? Oh, are you referring to the moons around Jupiter and stuff, or are you just talking about other exoplanets around other stars? That one I'm not sure what you mean exactly. Okay, so gosh, there have been a few examples of this. It's really, I gotta say, it's kind of hard for us to keep track. Back in the day when there were, fewer than 100 planets that were known about, it was a lot easier to know which exoplanets sounded really intriguing. But with our current slate of over 4,000 exoplanets, it is really hard to know which ones have planets in their Goldilocks zones. One I can think of right off the top of my head is named Kepler 62 is the name of the star. It was called that because the Kepler space probe had focused on one part of the sky and found many, many, many exoplanets. And in Kepler 62, they found a few that were actually terrestrial. So let me see if I can share with you a picture of this so you can see what I'm getting at. All right. Yeah. So this is an artist's conception of the system. And let me see if I can bring it up here. All right, here we go. Can you all see that? Is that showing, Waylena?
Yes.
Okay, thank you. So you can see our solar system at the bottom there, and then you see the Kepler-62 system up at the top. And in that situation there, you are seeing 3 planets are very, very close to the star, way too close for life to be possible there. It's going to be way too hot. But then there are 2 planets, both noticeably larger than Earth, Kepler-62e and F. They actually happen to be in that Goldilocks zone you were talking about. All right. So at that distance, the temperatures are not necessarily too hot or too cold for water to be a liquid. And so that's why they would say that those are in the Goldilocks or the habitable zone. Okay. Having the much larger world than Earth, I don't know what factors that can affect having life be possible there. It might be that there's no land that's exposed to the surface. It might be a water world, but still very neat to think about. And also, I'll add this. If you're wondering why the Goldilocks zone of Kepler-62 is so much smaller than the one that you see for our solar system, it's because that star is a lot dimmer than our sun. Okay, it gives off a lot less light. You'll notice the color up there is more orangish in color. Okay, I don't know if it's a red dwarf exactly, but it's certainly giving off a lot less light than the sun is. All right, I'll stop sharing that. What was our Q&A question? Are there other planets that have their moons in line like Jupiter? Well, the reason why we see them with their moons in line like Jupiter is because of Jupiter's lack of an axial tilt. So the cool thing is the moons around the planets like Jupiter, Saturn, Uranus, and Neptune, what we call Jovian planets, they have the moons formed in such a way that they're orbiting around the planet along the same plane as their equator. So if the equator's tilted, that means that those moons' orbits are tilted as well. So Saturn has a little bit of that tilt. So you saw the tilt with the planets, with the moons. Uranus is tilted on its side, and so all of its moons have an extreme tilt. And then Neptune's is pretty similar to Saturn's. The only other planet in the solar system that has a really small tilt in the way that you see with Jupiter, I don't think that it's proper to say that it has a really small tilt, because its tilt is more just upside down completely. Venus has an extremely small tilt, but it rotates in the opposite direction. And it's more likely that instead of it having slowed down and gone in the other direction, it's more likely that, pop, it got flipped. The brightest star? Whew, that's tough. I will tell you that there are some really, really, really bright stars out there. The stars of Orion, they're really far away from us, but you see them as so bright in the sky because they give off so much light. Stars like Betelgeuse, or Rigel actually more like, they give off hundreds of thousands of times more light than the sun does each moment. Okay, there are some stars that actually give off millions of times more light, which is a lot. Yeah, I wouldn't want to be anywhere close to those. Those are.
I was just thinking of Deneb and how far away it is.
Yeah, Deneb's actually like 3 times farther than Rigel is, and it's only slightly dimmer. So yeah, I can't imagine how bright Deneb would be. Oof. Yeah, no, thank you. Don't want to be anywhere close.
How many moons orbit Jupiter?
How many moons orbit Jupiter? Jupiter right now has only 79 known moons only. I say that because right now it's in second place. But it's expected that there are lots of moons that have not been discovered yet that are way out there and very, very small. It's estimated that Jupiter has possibly 600 moons.
Yeah, never write a planetarium show script to be recorded with the number of moons listed.
Yeah, at the turn of the century, around 2000, for a short time, Uranus had the most known moons. Uranus had like 18, and that meant it had the most. Uranus went up to 27, But then they discovered at least 60 more around Jupiter and Saturn.
And and Jupiter, I mean, there was one summer where you're reading the crawler at the bottom of the news thing saying, you know, that, oh, 15 more moons have been discovered. And you're like, they're still talking about that. No, 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 no. That was the 15 moons that were discovered a few weeks ago. This was a new set of moons. That was crazy to keep up on.
Yeah, exactly. That news, it's always fun when your work is outdated.
Well, for, you know, I'm old enough that for years it was 16 moons. 16. That was, so you're still going to find science books out there that say 16 moons for Jupiter.
Yeah, and the scientists had to start getting really creative with the naming of the moons too. They've even put some of those names out to out for public submission as well. So some of those have some really interesting motivations. So with Ellie's next two questions about temperature, a really good short way to remember the temperatures of the planets is that the farther they get from the sun, the less light their surface or their clouds are getting from the sun. So they're going to be generally colder. However, the warmest planet is not the closest one. Mercury can get very cold at night. And when you have something like a greenhouse effect, you can make a planet a lot hotter. And Venus, you saw, was covered completely in clouds. Every day is a cloudy day on Venus. So yeah, the astronomers on Venus are very, very sad every night because they don't get to see any of the stars. Okay.
We need a disclaimer note, there are no astronomers on Venus.
Not in my fan fiction, I guess. All right. So on Venus, the greenhouse effect is so strong, the temperatures are hotter than Mercury, and also hot enough to melt a lot of metals. Okay, like I think lead might melt on Venus. Yeah, it's extremely hot. Like we're talking in Fahrenheit 900 degrees, almost 500 degrees Celsius. Okay, not quite there, but really, really, really hot. Okay, so no space probes that have landed on Venus have lasted for even 2 hours. We don't want to waste the money, so we haven't tried in a while. Other questions, folks?
All right, well, we're just about to the hour, so it's a good time to sign it off. And again, remind everyone that 2 weeks from now, we'll have our first presentation in Spanish. Hope you can join us for that.
Yep, and it'll be right on the same Zoom meeting. We keep using the same webinar link. And if you're looking around and wanting to see other things in the night sky, or if you're wondering what satellite might have just passed overhead that you just saw, if you go to Heavens Above, that's a good place to check that. Spaceweather.com is always a great place to get neat pictures and to learn about potential aurora, the northern lights. And then there's always beautiful pictures on Astronomy Picture of the Day. They actually posted a lovely video today showing the ISS passing over things like the city lights, all that nasty light pollution, even though it's really pretty from overhead, and also showing some interesting northern lights as well from there too. Okay, so I hope those links will entertain you quite a bit. But folks, thank you so much for joining us this evening. We'll see you again in 2 weeks, or as they say in Spanish, 2 semanas.